My name is Adam, and I'm the Scientific Services Lead at Seqera. And in this role, I work closely with bioinformatics engineers, helping them get the most out of our software and their workflows. One of the things we see is that pipelines evolve. They grow in scope and complexity and accumulate challenges along the way. In this talk, I'm going to walk through some of those common pain points and show you how the Seqera ecosystem is built to reduce friction at every step. So we're going to talk a lot about Nextflow. So I thought I'd start with a brief introduction. Nextflow is a programming language designed for building bioinformatics pipelines. It was created at the CRG in Barcelona in 2013 and has since gained widespread adoption for its simplicity, its flexibility, and its ability to scale across a range of computing environments. And over the past decade, it's exploded and become the standard in academia and industry. In Nextflow, each step of your analysis is defined as a process, and you can encapsulate everything from the software to the data inputs to the data outputs in that process. The data is passed between each process as via channels. Okay, you can think of it like the metro map model, where the processes are the train stations, and the channels are the tracks between them, and your data are the trains moving along them. And one of the key strengths of this approach is Nextflow can abstract away the execution logic. It can automatically determine the correct order of operations. It can automatically run tasks in parallel wherever possible. This takes a whole load of development burden off the bioinformaticians' plate and allows them to just focus on their pipelines. Then it has a configuration system that allows you to write the pipeline once and run it in a range of environments, whether that's your laptop, cluster, or the cloud. And this intuitive structure and how it works with the bioinformatician is a big part of why Nextflow has become so popular. So who are Seqera? Seqera are the company founded by the team behind Nextflow. So our founders, Evan and Paolo, created Nextflow at the CRG, and we continue to develop and founded Seqera and continue to develop Nextflow as an open source project, and we're proud to be its stewards. Nextflow has been transformative for an individual bioinformatician, but Seqera was created to meet the broader needs of organizations, centralization, standardization, management, deployment. With Seqera, Nextflow evolves from a powerful workflow engine into a full platform for collaborative science. So I've introduced Nextflow and Seqera. Let's talk about the challenges a bioinformatician faces. One of the things I often see when working with customers is this transition from small Nextflow to big Nextflow. Okay, the evolution of a simple main.nf script to a fully tested, portable, production-grade pipeline. It starts with just a single workflow, a couple of processes, nice and concise, easy to manage, and then features are added iteratively. And as the pipeline is used in more contexts and used more for more purposes, it naturally grows until you have a fairly complex piece of software. But there are challenges at every step. So you might start with a single pipe step in your pipeline using one or two software tools, but it quickly grows into this complicated beast of a pipeline with which requires proper packaging and versioning and deployment. You go from running locally to an HPC cluster to the cloud. Tracking when, where, and how your pipeline was run becomes a full-time job, and especially when that pipeline is reused in multiple different projects. And running the pipeline isn't enough. You need to be able to interpret the results and make meaningful decisions. And these are roadblocks at every level, and they are compounding problems that slow down your science. So we're going to talk about all four in turn, starting with software. If you want to build a complex piece of software, good developer tools are essential. And we've just rolled out the VS Code extension. It's making developing, debugging, and expanding your pipelines so much faster and easier. You get a full-on IDE experience right there in VS Code, which means things like syntax highlighting, error checking, and even a graphical view of your workflow. All these features make it easier than ever to debug and develop your pipelines. And it's 2025, and that means if you're still getting stuck, you can just ask the machine. So we've developed Seqera AI, which is a language model optimized specifically for working with Nextflow and bioinformatics. It's designed to help with everything from identifying and fixing errors, to converting existing pipelines to workflow, to generating a brand new workflow from scratch. Importantly, it will not reinvent the wheel. It will use best practices and community standards that have come out of the Nextflow developer community, things like NF Core modules. This is ensuring you're using the best possible tools at every opportunity. Seqera AI is available direct from our website. It's also built right into the VS Code extension, which you can install from the VS Code marketplace. Uh, and, and you can access Seqera AI through GitHub Copilot, which means you can get real-time help without ever leaving your coding environment. Containerization is the right way to package pipeline software. It ensures stable environments and is arguably the only way to do reproducible scientific analysis. But creating Docker or Singularity containers is not the best use of a bioinformatician's time. They should be doing science, not wrangling containers. And that's exactly why we built Wave, a container provisioning service that automatically builds and deploys containers based on the needs of your Nextflow pipeline. So you just specify that this process requires SAM tools, and Wave will go away and build you a container with SAM tools and use it in the pipeline. But even that might be a bit much, and so we wrapped Wave into a public service called Seqera Containers. So you just visit the site, select the software packages you need via conda or pip, and Wave will just build a container and publish it to a public registry, complete with a security scan, ready to be used. It's just making the barrier to using containers lower for every user. Okay, these tools enable you to build bigger and more complicated pipelines with confidence. But we're still developing on our laptop. What happens if we need more storage? We need more horsepower, and we need to increase our computing capacity. This is where Seqera Platform comes in. Seqera Platform is our primary interface for managing and running Nextflow at scale. One of the cornerstone features of Seqera Platform is its ability to create and manage compute infrastructure. You can easily spin up environments on the cloud or on premise directly from the interface without needing to dig through complex options or manage roles and purposes and all these things that you shouldn't be thinking about. Pipelines can be launched directly onto these compute environments straight from the platform without having to supply extra configuration or credentials. You just select the compute environment and go. And it's purpose-built for bioinformatics workloads. Features like automatic scaling, resource caps to control costs. It includes support for spot machines, for GPUs, reflecting the diverse requirements of bioinformaticians and bioinformatics pipelines. If that still feels like too much work, we've recently introduced Seqera Compute, which is a fully managed compute service hosted and managed by us. When you choose this option, all you need to do is select a region and a name, and we'll handle everything else. Compute brings together everything we've learned from running production workloads across a wide range of environments and packages it into a single, easy-to-use solution. Both of these options are powered by Fusion, which is our high-performance file system. Fusion streams data directly from cloud storage during execution, eliminating the need to download or upload files. This delivers two key benefits. Firstly, faster pipeline execution because you're removing that extra step of data transfer. Secondly, it provides freedom from managing intermediate storage. So you don't need to configure and manage drives, NFS storage, anything like that, which might fill up or fail or require backup and maintenance. Your team can focus on analysis rather than infrastructure. So now with Seqera Platform, we can use distributed compute environment and scale bigger than ever. Your pipeline is now in active use, which means you need to keep a complete and accurate log of how, when, and where each analysis was run. Keeping track of these can be a real challenge. You can try to document everything manually, but there's no guarantee it will be accurate or complete. Sure, you might capture the parameters and settings, but what about deeper details like pipeline configuration or the internals of individual tasks? This is where Seqera Platform comes in. When you run a pipeline on Seqera Platform, every pipeline run is monitored end to end. Okay, no more digging through emails or Slack messages to try and find the right config or output. Everything lives together in one place, and you can follow the execution live. And after the run, you get access to detailed metrics and logs all the way down to the task level. If there's an error, it's reported in plain text direct inside the platform. Failed tasks are clearly highlighted on the run page, so your attention goes to exactly where it's needed. You can dive deeper without switching tools. So you can download logs directly from the platform or explore task directories using the built-in data browser, which means debugging becomes faster and more focused and far less painful. Each pipeline is grouped into workspaces, which grants you which is the shared environment where your team can work. You can invite collaborators or internal team members into each workspace and grant them only the permissions that they require, giving them really granular access to each pipeline run and data within. This means you're all working from the same source of truth, and they're bringing a clarity and consistency to your science. So we've now seen how Seqera Platform provides a unified view of your pipelines, but analysis doesn't stop with pipelines. Results need to be interpreted and presented clearly to make a conclusion. So bioinformatics results are often messy and nuanced, and this makes them difficult to communicate, especially to non-bioinformaticians. Figures are the best way of conveying a message, but generating one involves passing the raw outputs of a tool, standardizing their format into something structured, and then building a plot. MultiQC, which is a tool developed by Seqera, was built to solve this exact problem. It aggregates and standardizes results from your pipeline into one single easy-to-read report. It's got built-in support for 165 different bioinformatics tools, so you shouldn't need to write a custom parser to get a clear, representative view of your data. If a tool is not supported out of the box, MultiQC can be extended using its Python-based module system. But if you need even more flexibility, you can actually import MultiQC as a Python library and just use it directly from within your scripts to generate a fully customized report. MultiQC's role is to make it easier for your whole team to interpret the outcomes of a pipeline and make an informed decision. And MultiQC is 10 years old on the 4th of August, 2025. A pipeline is ultimately just a data transformation engine. Okay, it takes raw data from a sequencing machine and turns it into a different format of raw data. Without proper analysis and interpretation, it's incomplete. Okay, and too often analysis happens downstream. Users download the outputs to a local machine and work in an isolated environment. This breaks reproducibility and increases the risk of errors, as well as increasing cost. Studios is our version of an interactive analysis environment. It's available from Seqera Platform. It's got three core advantages for bioinformatics. Firstly, it runs inside your compute environment. So Studios launches directly into your configured infrastructure, reusing your compute environments and inheriting your pipeline setup. There's no need to manage like a separate set of infrastructure just for data analysis. You have one compute environment for infrastructure, for analysis and for running pipelines. Secondly, it's backed by Fusion, which would provide for instant access to the data. Fusion file system streams data directly from cloud storage with no need for large local disks or copying files around. Finally, it supports all the tools you need. Studios includes out-of-the-box support for Jupyter, R, VS Code, and even full virtual desktops. But it can be customized further using Conda. So you can inject additional software dependencies based on your analysis you require. Finally, you can build completely custom containers to do whatever analysis you need, such as this cell by gene example that we're showing here, which is an entirely custom interpreted piece of software running on Studios. Studios is the ideal shared analysis space for computational biology teams, and it empowers you to turn data into decisions. So we've provided the tools for analysis, and we've turned raw pipeline results into informed, actionable decisions. And this completes our transition from small Nextflow to big Nextflow. This is ultimately the core mission of Seqera, to unblock bioinformaticians at every step by removing technical friction. You shouldn't be spending your time managing infrastructure, juggling software environments, or tracking down results. Okay, your science should not be slowed down by the work around the work. Here is a list of the products mentioned in this talk. Nextflow, MultiQC are both open source. Seqera Platform has a free tier for allow you to explore and try it. Seqera Containers is available direct from our website, and Seqera AI is also available direct from our website with an account. We have an Nextflow Summit coming up at the end of the year. The summit is virtual, and then we have a training and hackathon at home base in Barcelona on the 28th and 29th of October. Thank you for listening.